Okay, 2022 May, June, paper 13 and 23. We are now going to do electric current and DC circuit. Thirty-five. Are you happy with the answer or you want me to explain further?
So
Okay. How about this one? What's the answer?
speaker.
Say again.
This one I should be a loudspeaker.
No. Buzzer,
Oh,
go into your syllabus. All the symbol you need to know. Okay. First is the syllabus.
okay.
They give you a list of symbol that you need to know. Okay, which is the correct? Which row is correctly described Kirchhoff's law? Yep.
A.
Okay. Good. How about this one?
Boy.
Which combination must cause Vx to be increased? You want this one to be large. And this one to be large, increase. So you say boy, large Rx. Okay, good. Rx must be large, Ry must be small or smaller. Okay. Okay, this is memory work. How do you explain the shape?
The shape sign. Yeah.
Yeah, how do
Wait,
you
no.
explain the shape of the line?
Increases. Uh,
Basically must go to the ratio of resistance is V over I. Then argue from there, no? V over I. V over I increases. The ratio of V over I increases. No? As I increases, temperature of the filament wire or the lamp increases. Or as I or temperature of V increases, the resistance of the wire increases. As I, actually you don't have to use I. You can use either one of them, either I or temperature or V increases. The graph curve, because the ratio of V over I increases or ratio of the I over V decreases. Okay.
mm.
Conducting wire has a length of 5.8 meter and cross-sectional area 3.4 times 10 to the power minus 8 meters square. Resistivity of metal wire is 5.8, 5.6 times 10 to the power minus 8 ohm meter. Right? Resistivity can expect paper 1 and paper 2 to come out. Lah. Calculate the resistance of the wire. Resistivity formula now, that's all. Can resistivity is given
Yeah.
by L is 5.8, and cross-sectional area, everything is given you. No need to change the unit. Unit is changed for you already. Okay with that?
Yeah.
Resistor or resistance R is placed in the circuit with a cell of negligible internal resistance, two switches S1 and S2, a second resistor of 2R, and three emitters. These are three emitters. X, Y, Z. The reading of X is 1.0. This one is 1.0. When S1 is open, S2 is closed, complete the table. Right? What should be
Reading on Y/A0. And then 1.1. Yeah, 1. And
X is
then
what?
2, 2, 0.
20200. Okay. Basically, the potential difference of EMF is the same. So when you close S1, you must know you close S2, close S2, right? This is 1 ampere. This is also 1 ampere coming through. Then you close S1, open S2, close S1. Right? Previously, told when you close S2, there's 1 ampere there. So basically, it's I is 1, and then 2R. So this one is constant. Right? We are basically using this equation. So now you close S1, is R, so the current must be 2 ampere. 2 ampere pass to here, pass to here also. So when both of them are closed, what is the answer for X?
3,
Y?
then 2, and then 1.
Just follow from here. X is 3. Right? Potential across each of them is the same. So across R, same as here when you close down. 2 plus 0 is that. 1 plus 0 is 1. And add these two together, you get 3. Okay with that?
Yes.
Okay. A bit louder, cannot hear.
Okay.
Okay. That is, I think we have completed. I hope you have done the year by year.
Uh, I 2022 February, March, haven't done yet. Haven't done finish yet. The rest can already.
You must make an effort to learn now.
Yeah.
You are sitting the
I,
exam,
I no, done already. Yeah, done
If
already.
you don't do it, then you are wasting your time having tuition.
Yeah, one paper I haven't done yet. Just one.
Which paper have you done?
All except 1, 2. As to uh 1, 2 are basic. The 22 are done. I mean paper 2 I'm done. Paper 1 not. Paper 1 I got do halfway.
How about 2022 October, November, paper 1-1 and paper 2-1? Have you done
Yeah,
that?
yeah.
Okay, then we discuss this one. Make sure you make an effort to do it. If not, you're wasting your time here. Thursday, I won't be free.
Oh, okay.
Okay. Uh, why is happening? Okay, we will discuss this one. 2022 October, November, paper 1-1 and 2-1. If you haven't marked,
Okay.
mark yourself lah. And then you should give yourself your score and you should improve. And by doing the paper, you know where is your weakness and then improve on your weakness.
Mm.
Okay, that's how you are going to improve in your skill for physics by learning where is your weakness, which area is your weakness. Okay, what is needed to accurately represent all physical quantities?
C.
Okay, good. A voltmeter connected across a resistor as a circuit reach 3.6 volt. What would be the current in the resistor and the resistor? Okay, what's your answer?
他不懂 key
Yeah, this one no choice. You have to work through all of them. Previously, the answer is either A or B. But now it looks like you have to work through all of them. Okay, good. How about this one? This is a repeat question.
8%.
Yeah, what's the answer?
C.
Right? 2 doesn't have a percentage error. It's a constant. 8%, yeah, right? C, which quantity is a vector?
A.
Okay, good. How about this one? Particle accelerates from rest. The graph shows the variation of velocity of particle with time t. Which graph shows the variation with velocity v and acceleration a of the particle? This one make you think through.
That is D, right?
Yeah, donkey. The acceleration is constant. Velocity is the one that is changing. Good. How about this one? The graph shows the vertical velocity of a parachutist during the first 20 seconds of a jump. Approximately how far does she fall before opening the parachute?
So my answer I got is like
Well, you
estimate
open
lah,
the
but it's close
parachute
to
about
B.
here, about here,
Uh,
about 13 seconds. So you are expected to approximate lah by drawing area under the graph. Approximate with triangle and rectangle. It's an underestimate lah. We have removed this part. We have add a bit here, that's all. So the parachute is open at 14 seconds. Distance is area under the graph. Right? Approximate, you just want as fast as possible. Right? Don't want to be accurate. Right? Area of triangle, that is your base. Base is 9. There's 60 there. Then 5. This is 5. 60. Okay, out. We got this answer. But ours is underestimate lah, but you can see we are quite accurate. B. Okay. This is memory work. Definition of linear momentum.
See.
Yep. Yep. Memory work. Definition.
See.
See. Right. There's your spring. There's your mass. Attached to the mass is another 0.1 kilogram. Let it stabilize. Then you cut the string. You want to know the acceleration immediately after you cut the strap.
Is it B?
Right? Basic idea is this is the one that provides the force, and the force is the one acting on this mass. Right? Force applied by the spring, right? Due to this one. Right? As your weight is mg, 0.1 times 9.81. There's a force applied to this mass. Right? Because the spring apply the force to this mass. So it's F divided by M A.
Oh.
Okay. Any comment or any question?
Oh, acceleration upward. Oh, okay, yeah.
Yeah, because the spring is pulling outwards. When this mass is missing, this mass is the one that provides the extra force. And this force is acting on here. Okay, how about this one?
A. So I put A.
Right? No, the force is acting. No? The wave pulling down, friction or air resistance is opposing it. And then your mg, acceleration is mg minus f divided by m, mass of the snowflake or raindrop. So friction, right, or air resistance, this one, f takes more time to reach terminal velocity as f depends on the speed and surface area. Two things, speed and surface area. Snowflake has a larger surface area. Since at the same speed, the drag force on the snowflake is larger than raindrop, the snowflake reach terminal velocity first. Okay with that? A, good. How about this one?
Monkey.
Right? This spring is compressed, then you release it. How much elastic potential energy was stored on the spring? So you have to work with conservation of momentum first. Right? Initial momentum is 0. So momentum to the left, this one. Momentum to the right. Right? If you don't want, you just take this across there, it's 0. Right? Final momentum is 0. Where v is the velocity of 1 kilogram. Right? Velocity of this one. 4. Elastic potential energy equals to total kinetic energy. Right? Where you release the spring, the kinetic energy is given to 2 kilogram trolley and 1 kilogram trolley. There's a 2 kilogram trolley. That's why the kinetic energy of 1 kilogram trolley, 12 joule. Donkey. Okay. Any comment?
Hmm.
Okay, you're
Oh,
happy with that. How about this one?
oh, this one ah. So I put D.
This one, the center of gravity is the diagonal, no? Along the diagonal. Right? Let the diagonal be D, let the diagonal be L. So the center of gravity is midpoint, no? Midpoint of D, midpoint of the length L. The length of diagonal of square P, and X square is so diagonal is in terms of X is X squared. So it's X square plus X square is X root 2. CG is the midpoint of diagonal. Right? We can take it from P. That center of gravity is here. So it's 0 half of this one.
Yeah.
Same thing. You can find L in terms of the side 2x, 2x square, square root of the whole thing, plus that together, we get 2x over root 2. So CG is from Q is half of this length. Okay? Half of this one is that one there. Then we take the difference. The CG is here, the CG is here. Take the difference between two of them. X root 2, 0.5, and x root 2. Okay, that's your that. That's your that. So instead of giving you 0.5 root 2, you multiply by root 2 here, denominator and numerator by root 2, then you get your answer. Happy with that?
Hmm.
Funny way of testing. Basically, this involves a lot of maths as well. How about this one?
So it looks like boy. Ah. Oh wait, object equilibrium. Oh
Yeah. What's the answer?
Oh, equilibrium means A.
A, no? Forces upwards, F. Forces downwards, F. Rotation or not? Cannot rotate. You rotate
Yeah,
clockwise, the
cannot rotate.
same. Anti-clockwise, the same. The answer is A, no? B, B, vertical equilibrium got, but you will rotate anti-clockwise. C, right? It
It
will
will move.
upwards. It will accelerate upwards because this 2 is greater than that one there. Donkey, uh, downward forces is F, upward forces is F, so vertical equilibrium, but will we rotate? You can take moment about one end there. Right? Is it in equilibrium? It will rotate, because that moment is greater than this moment, no? Okay? So you rotate anti-clockwise, no? If you take moment about this part there. How about this one?
So this why I skipped this question because I didn't know what it means. Like, like how is it rotating and stuff?
This is a track. This is your rigid rod, negligible mass, so you don't have to worry about the weight. Then you attach a a mass of 11 kilogram by a thread there, 25 cm from this end. Which vertical upward force acting at Y, right? Vertical force acting at Y of the rod would hold the rod vertically. Look at the forces acting on the weight. The weight will produce this tension pulling it down on the rod. Right? 11G. G is acceleration due to gravity here, not gram. Right? And there's a tension in this string here. So it means there must be a force downwards. So the force must be downwards. So sorry, the force must be upwards. So
Forwards, yeah.
yeah, because if you take moment about X, the weight is going to cause clockwise moment. So we must have an anti-clockwise moment going that way. No? So let it be F. No? Taking moment at X, no? Because X is not given. This one is given. Okay? Easier to take moment about X. No? Clockwise, some are clockwise moment, got some anti-clockwise moment. No? 11 gram, 11G, sorry, 11G times 25. Don't worry, you want to change the unit can also, but it doesn't matter because our force will be in Newton. Our distance, if you use meter, it will come out as meter. If you use cm, it will come out as cm. So 11G times 25 cm, F times 75. Okay, C, Ken, any comment?
Hmm. But how do you know 11G is acting clockwise?
You take moment about X, let the force pull, it will go that way. Right? You are holding this part, so you are pulling
Oh yeah,
it
yeah, it
down.
moves
So this
clockwise.
one is clockwise. So
Oh yeah, yeah, okay, okay.
any other comment?
Yeah, that's it.
Density of water is given. Density of glycerin is given. Water is added to a measuring cylinder containing 40 cm glycerin. So the density of the mixture is 1.1. Assume that the mixing process does not change the total volume of the liquid. What's the volume of water added?
D.
Yep, what's the answer?
Donkey. I got donkey.
Donkey. And let the volume of water added be V. Total volume is 40. 40 plus V, right? Glycerin plus water. Mass is density times V. Density of water is 1. Volume is V. Mass of glycerin, right? Density is 1.3. Right? We are using gram times 40 cm cube, so it's 52. To find the total mass, right? To add together total mass. So okay, we got 10 more minutes. Right? The final density or average density of the mixture is total mass or total volume. Right? You are told that the density is 1.1. Total volume, take across there. Right? That's your total volume. That's your total mass. And substitute. Okay, donkey, good. How about this one?
C.
Okay. Upthrust is V rho G. Right? The area is constant. Cross-sectional area A is constant. That right. Depth depth of the lower surface below the surface is H. So it's a straight line. But when the box is completely it will increase as it goes down. The upthrust will increase because the volume increases. So when the total volume is inside there, then it's constant. Okay, good. How about this one?
Teacher, just not that one, the depth is flat line. Yeah. Depth.
The depth is your height, lor. Height below the surface of water, lor. That's the
Is it
depth.
because it's a
The depth initially is this length, lor. Is this height, lor.
oh
Right? So sorry, the depth is below the surface. Initially, it is zero when it's on the surface. As it go down, the depth start to increase, lor. No, the upthrust start to increase also, lor. If we know it's a straight line.
but if flat why does the upthrust suddenly like uh
No
constant?
more depth already, ah. The volume is constant, ah. Volume is constant.
Oh,
This is not a good formula lah. This formula will tell you this way, but the upthrust depend on volume of the box. So when it's completely inside already, it's constant already. No more upthrust doesn't increase anymore. So initially it depends
the teacher,
on
but according to the graph C, right,
ah
the depth is
zero
still increasing.
zero after a certain when the volume is completely inside the water, then it's constant. No? Upthrust is constant. No? Normal change already as the depth keep on increasing.
Oh, but the depth is actually not increasing, ah.
The depth is
Yeah,
actually
okay.
actually you cannot use this formula completely lah. This formula will tell you is A, but initially the depth is basically the length that is below water, the height that is below water.
Mm.
So when all the height is below water, then after that the upthrust completely constant, no? Because upthrust depends on the volume of this solid, volume of this solid.
Okay.
Okay, okay,
Mm.
okay, number 16.
D.
Okay, good. 17.
So I got C.
Right? mgh divided by T. Mass of the man is 75 kilogram. G is 9.81. You have got 30 steps. 30 steps. Each of them 20 cm. Change it to meter. 0.2 time. Time is 7 seconds. Okay, good. How about this one? What is the speed of alpha particle? Energy is given.
Oh, C.
C is it?
Yeah.
Okay. Basically use the kinetic energy formula and subject velocity or speed. Kinetic energy is given. Right? That half becomes 2, you cross multiply. Then alpha has 4 nucleon. Mass of each nucleon is that one. Right? Use atomic mass unit. Okay, good. How about this one?
Oh, this one, ah. This one, I think it's C, lah.
How do you decide is C?
Because there's two sideways and two upways. Well, no, two horizontal and two vertical to balance out into one.
Okay, that's a good way of analyzing it. I use maths, extension the E for one load for one spring, right? The load, let it be W, and this one, the extension will be E, so it's 2E, lor. So the spring constant is KAW, and this one is, each of them will be half E over 2 divided by W, right? The original one was K equals to W over E, lor, right? One spring connected a load, extension E, right? Yours is faster, lah. So the KC is, got this one there. Each of them have half extension is E over 2, so completely E, lor. There W, lor. So that's the answer, correct, lor. C. And our unstretched spring has a length of 2.0 cm. The spring is then stretched within its limit of proportionality by tensile force of 1.5 Newton, so that the elastic potential G law in the spring is 0.45 joule. What is the stretch? What's the stretch length of the spring?
D.
Right. That's the elastic potential energy formula. So if you use this formula, then X is 2 cross multiply, take F down. 2 E is given as E, F, S is 1.5, so it's 6.0 cm. So the stretch length will be 6 plus 2, original length is 2. Okay, happy with that?
So extension was 6 and then plus the unstretched.
As a 2, the original length and stretch length.
Huh.
Okay, any comment? Anytime it may be
Nope.
cut off now. Okay,
Huh.
what's the answer?
Not correct.
Yep,
A. A.
not correct. A, okay, good. How about this one? This is compression. Compression, reflection is around here. Reflection is around here.
This one, yeah. This one should be B.
Nope. Right? From compression to wavelength to wavelength. Compression to compression is the wavelength, no? Right? 0.5.